Hello everybody, this is a tutorial video about Mimir. Mimir is a shipwright's assistant. He's not much help in survival mode, but in creative mode, if you're creating a ship, Mimir can let you make your ship do a lot of really cool things that you would have really struggled to do earlier. I'm going to show you how to do it right from the very most basic stuff all the way up to controlling fleets. I think you're going to like his capabilities, but I'm afraid this is going to be a long video. Let's get started. To use Mimir, you're going to need a programmable block. I know, shocking. Mimir is a script, so you can use him in any universe that allows scripts. He doesn't have to be imported. You'll find him over here. I haven't actually released him yet, so I will be copying and pasting from off-screen. I usually name him Mimir because I have to find him, and you're going to have to find him as well. You're going to have to look him up a lot, and so name him something unique. Mimir, in fact, works off of names, so you should be naming everything you plan to have Mimir interact with something unique. We'll see more about that in a second. This ship has 2 docking ports, as you can see. Now, if you have docking ports, there's always going to be an urge to show their state, full or empty. And normally the way you do that is you get one of these LCD panels and you load it up with a cross like this, and you turn this on and off depending on whether the ship was parked there or not. Well, we're not going to do it that way, but we are going to rename these because we are going to want to make sure that there's no other LCD panels with the same name. And also it helps if we have regular naming patterns, because otherwise we'll get confused. Let's add in some blocks, lights, sure, and some sensors, sure. And again, we're going to want to name all this stuff. So this is connector A, and this is connector B. And this is, oh, I forgot to turn on mirroring. That was stupid. Oh well. And this is sensor A, and this is sensor B. And this is spotlight A, and this is spotlight B. And let's make them purple. So normally, if you wanted to adjust both the spotlight and that text panel, you would have to have a dedicated timer block whose existence is only to do those 2 things, and then you'd hit trigger now a whole lot. That's really wasteful. You don't need that anymore. We have Mimir. So when you want to call Mimir, you find him and you hit run. You can also drag it down and hit run if you don't want to do it in the exact first block, and then you give him an argument. The argument is the names of the blocks that you want to affect and the call that you want to make. So spotlight A dot on, semicolon if you want to put in more than one command, and then the other block, so panel A dot image cross. You don't need to end with a semicolon. Notice there's no quotes or anything. This isn't proper C#, it's just a string. And then on the other side we can do the same thing but with different arguments, see? Now we're going to repeat the process for sensor B. But of course, for these B's. Easy as pie. So if we were to take a look, nothing has changed yet. The reason for that is pretty simple. These don't actually fire until you cross their boundary. But once we cross the boundary, see? So even as it stands, we've already made all trigger now blocks obsolete. If you were doing timers just for trigger now purposes, you don't need to do that anymore. In addition, our text blocks are now much more powerful than they were because we can change which image or text we're showing with a command rather than using any kind of advanced C#. Let's do something a little bit more complex. How about we build one of those command seats where there are screens that will actually respond to you. So let's put rotors in here and here. Why not? Rotor. And then panels on these. No, that's not a panel, that's a programming block. That's a panel. There we go. So what we'd like to have happen is that when you come in here, we would like them to be like that, but when we're actually sitting down, we'd like them to spin 45 degrees so that we can see them when we look left and right. So That should be relatively straightforward. Let's put down a sensor. We're going to want to set up all of these pistons and panels with their unique names and attributes as needed. So we'll go ahead and presume that this one is panel A, although we might be wrong. I might have to check that. Oh, sorry. Command panel A. You don't want to name the same thing twice. Two panel A's, and Mimir might choose the wrong one. Command panel B. And this would be command rotor A and command rotor B. Easy enough, right? And this is the command sensor. So what do we want to do? When we step within range of this sensor, we would like for the panels to show specific things, and we can do that by running Mimir. And we can say command panel A dot text, no quotes, welcome commander. And then we can say semicolon, command, oh wait, this is getting really long. What if we want to change it later? We can't call this stuff back up. I mean, look, we can't re-edit. It doesn't let us re-edit it or see it. That's too long. That's too much nonsense. Can you imagine having to type that stuff out, and then if you get one letter wrong, you've got to start over? Oh. Cached commands. So we can type in something short here, like command area, enter command area, and then we can type in as long a command as we would like command text a dot text, welcome commander, semicolon, command text b dot text, take a seat. Now, I recommend using an editor such as Cite or MonoDevelop or Visual Studio or something, because we are not getting any sort of color highlighting. It's very difficult for us to tell if we've accidentally got an extra quote or something, we've forgotten a comma. So you may want to use something outside of this code editor. I'm only using this code editor because it's quite easy to film. Exit command area. Command text a dot image arrow, semicolon, command text b dot image arrow, comma. So this is very, very basic stuff. This isn't even really C#. We're just filling in this array with our commands, the name we want to pass it, and then the long-ass command that we want to actually use. There are a lot of reasons to do this, and it'll become very clear in about 30 seconds why we're doing it this way. But even though this is technically C# editing, you shouldn't have any difficulty. This is the exact same string you would have been typing in as an argument. Check your code. Always check your code. And then hit exit. Let's go on over here and make sure that this block will fire those commands. Enter command area. Exit command area. It didn't work. What went wrong? No block found. No block found. So we typed it wrong. Command panel. What did we call it? We didn't call it a command panel in our text, did we? We called it a command text. See? You're going to want to make sure that all of this stuff is saved in a place where you can actually edit it rather than just being confused all the time. This is a lot better than having to just guess at what we typed wrong and retype the whole thing, or use cut and paste a lot. Sounds miserable. There we are. But these are definitely not the right size, so let's go ahead and grab them and expand them. Also, we got them backwards. This is command panel B, and this is command panel A. Oh, now all I have to do is make these rotors spin. Let's go ahead and make that happen. Go back in here, and we can just add another command. Semicolon, star, command rotor, dot reverse. So what happens here is star command rotor actually tells it to find all of the blocks with the word command rotor in the title anywhere, and make sure that this is applied to all of them. Now it fell off the right hand side of the screen, and it's actually not legal for you to split this into multiple lines unless you're going to be using more advanced operators, but that's okay. If you're getting to the point where you need this many commands, you should be using another text editor. Command rotor.reverse. You could also use rot plus and rot minus, which are commands I've given you to help you manage these rotors, but in this case we've got two rotors and they need to move in opposite directions, so we'll just use reverse. I didn't actually check whether the code worked. Yeah. But we haven't actually set those rotors up to do anything, so let's go ahead and do exactly that. The rotors don't have any kind of extent, so let's go ahead and both max braking torque and a much lower torque. So the command rotor A, I believe, is on the right, and we're going to want a lower limit of 0 and an upper limit of 45. Command rotor B, we're going to want a lower limit of negative 45 and an upper limit of 0. And we're going to want to make sure that our velocity is 10 and negative 10. Oh, setting up rotors should be old hat for you by now, right? Yep, should work fine. Now those screens don't have to show arrows. Later on I'll show you what they can show. We have an adaptive UI element here that we can use, and that'll be real powerful if we decide to use it. But right now, this programming block looks a little bit lonely. Like many programming blocks, this script gets along best with a timer. If you set up a timer to call itself and the programming block, then you can do a lot more with the programming block. No argument, just like that. 1, start. So now it's running every second. Nothing has changed from our perspective because it still does all of this stuff exactly the same. But what is it doing now that it has its command to run every second? Well, let's go ahead and set up some reactors. Yeah, like this. And let's go ahead and set up some batteries, like this. There we are. Batteries and reactors. So when we are running every second like this, every block on the ship is now a sensor and can fire whenever something changes. So in this case, we're going to have it so that these batteries change their state depending on whether this reactor turns on or off. So if the reactor turns on, we'll have them turn to charge, and if the reactor turns off, we'll have them turn to discharge. And we may as well also drop a sound block on so that we can get a nice alert out of them. Now I'm going to leave these batteries just named battery, but let's go ahead and name these large reactor A, large reactor B, sound block A, sound block B. Let's punch up the range a little bit and give them this alert. Yeah, that'll do. So what sort of code do we want to write here? Well, we have to write it in here because there's no place for us to put this code here in the reactor. And even if there was, it would probably be too long to fit onto the screen. So it's good to put it here in our Mimir. Down here we can see this custom logic area. In fact, we already have the custom logic we need. So these are currently commented out, and we can uncomment them out, or we can choose to recreate them, and we're going to go ahead and recreate them because I want to type them for you, so I'm just going to delete these guys. We're going to have to put in the end comment again, though. So we're going to say if check high. So there are a couple of commands here. Check will always fire whenever the state changes. So a reactor goes from 0 to 1, check will fire. A reactor goes from 1 to 0, check will fire. And the reactor changes state whether there is a turns on or off, gets damaged or destroyed, runs out of uranium, those things all count. But we don't want it to to just fire whenever that happens. We want it to only fire off certain things if it turns on and certain things if it turns off. So we're going to say if check high large reactor A, then we want to turn all the batteries to charge. So star battery dot charge. Now battery dot charge is a command I've given you which will allow you to change battery state to charging rather than toggling it. And that's important if you wanted to actually do anything with batteries. We are also going to want to say else if check low large reactor A, then we want to turn all the batteries to discharge so that we have energy. We also want to play an alert, so sound block A dot play sound. Now play sound is not something that I'm providing you with. Play sound is a default keen command. You can find a list of default keen commands in their documentation, and I've also got a whole bunch of them down here if you have decided that you wanted to get into it a little bit more. But that should work, but that's only one of our reactors, so we'll just cut and paste for the other reactor. B, B, B. Now, obviously, all of the batteries are responding to both reactors, so you are going to run into situations where if one reactor is on and one reactor is off, you may get something a little unusual. In addition, the very first time we remember an exit, we're going to have the problem where they fire. That's not really a problem, that's how it works, because we don't know what the state was. We just recompiled. We don't know what it was a second ago. We only know what it is now. So all of these batteries have just turned into recharge mode. See? Now, if we were going to go ahead and kill off one of these reactors, pretty useful, don't you think? You can, of course, do that same thing to try and rig up your refineries to give you an alert if they're not refining anything, or your assemblers to give you an alert if they're not assembling anything. There are a lot of things you can do with it, but let's go ahead and investigate something we can do with it very easily. First off, turn you back on just so that you don't beep. Let's go ahead and create a ship. There, a mining ship. Now, as I've explained a lot, this works off of names. It really has no concept of direct references to blocks. It only understands names. So let's give one of these names, one of these drills, a special name. Be aware that sometimes saving does not actually save the name changes. There is currently a bug where it will screw up and it won't save your name changes. I can't do anything about that. That's a bug in how Keen works. So if you find that one of your blocks keeps reverting its name, that's why. So what do we want to do about that miner? Why did we set it up to have a special name? Well, why did I suddenly turn pink? Interesting. Either way, we'll want to put in another panel. We'll put it in right here. And we'll call this the miner panel. I'll call it the drill panel. Drill panel. And we'll make it a little bit bigger. Oof. So what do we want this drill panel to do? Well, let's go ahead and enter into some commands here. Mimir. That's our cached commands. Here we are. We want this. So let's just delete this for now. You can use it if you'd like. It's fairly straightforward. And let's say if exists special drill, then we want to override that drill panel. Apply drill panel dot text drill exists. Oh, I put in too many quotes there. Sorry. There we are. Now, remember, I really recommend doing this in something that does highlighting, because that error would have been very hard to catch if you had typed it in and couldn't figure out how to make it work. Drill panel.text reconnect drill. Reconnect driller. Driller. Like so. Check your code, hit remember and exit. Reconnect driller. Alright, let's reconnect the driller. Yoink, and park. Come on. Drill exists. So what's the point of that? I mean, if we unpark, it's going to go back to saying reconnect drill. That's kind of pointless, right? Don't worry, we're getting there. So, we're going to go ahead and change what is in this line. If local special drill, memorize special drill, and apply drill parked. Else, if it's not local, apply drill on mission. So, if it's local, memorize it. If it exists and it's not local, say it's out on a mission. By the way, the reason this turns on for me and not it is because we never changed the sensor from a default of detecting people and not ships. So if we were to pull up our handycam here, shoof, shoof, drill parked. Let's unpark. Drill on mission. Now, memorizing things is great, but you have to recall that whenever you load the game or whenever Mimir has been recompiled, he'll forget everything he's memorized, and that's why it's important for us to have that reconnect drill command, so that we know to reconnect the drill if Mimir can't see it anymore. It's on a mission because I'm not actually connected right now. I'm floating half an inch above. But there is more stuff we can do here. We can also say else if is high special drill apply drill drilling. Yep. Once we've memorized it, we can continue to interact with it and figure out whether it's on or off. Now, you may have wondered why I'm using check high and is high rather than things like check on and is on. That's because on has a very specific meaning. These values here that are coming for us, these are actually based on a system called a status. So we can call for the status of the special drill, and that actually returns a value between -1 and 1. Let me just triple check that it's called status, because it's not something you normally would use. Yeah, status. It'll give you a value between 0 and 1. For something like a special drill, it's a 0 if it's off or broken, and it's a 1 if it's running. And by running, I mean turned on. Firing it with your mouse button, that doesn't actually count as it being on. It's just a weakness in Keen's interface. But something like a battery, 0 is no energy in the battery, and 1 is completely full. Whether the battery is on or off, charging or not, doesn't matter. And except for if the battery is destroyed, it's a 0, but otherwise, it's the amount of power in the battery. And for a cargo container, it's the same way. It's the amount of cargo in the cargo container. So it is high and is low rather than strictly being on or off. The rotors actually is high and is low are how far between the low and high maximum value on the rotor. And for pistons, it's the maximum and minimum value of the piston. So is high and is low really is not is on. And I've just basically put in the values that I think are worthwhile. Yeah, I want to remember the changes. Forgot to, check it. So let's go ahead and hop in our driller. We're detached, but if we hit this button, it says reconnect driller, because we recompiled and it doesn't remember the driller anymore. So we'll reconnect, drill parked, disconnect, drill on mission, fire up our drills, drill drilling. And that will continue to work no matter how far away the driller gets. He could be on Mars, and you'd still be able to tell. Now let's go and talk about our most powerful tool, and that is the UI for the player. We can create an adaptive UI. So what I've shown you so far is the ability for us to create triggers off of any block. So if the reactor goes down, you can turn on the batteries. If the solar panels run out of juice, you can turn on the batteries or turn on the reactors. Or turn on the gyroscopes and spin your ship. There's so many things you can do with this to make your ship more reactive. Call out the player when your refinery is not refining anything, for example. But really, what you want to be able to do is talk to the player. You want to be able to tell the player the status of the ship and let him manipulate it in exactly the way that you would like to have that manipulated. So we're going to use one more screen, and we're going to go ahead and put it right here. We're also going to go ahead and use a button panel. Button. And what this will be is this will be our main command area. Now, we could also make it these guys over here, but that would take a little bit more doing just because we also want them to interact with this. So I'll get to that in a minute. We'll go ahead and make it here first. How do we make this work? Well, we need to remember this name, command panel, and then we need to come over here, and we need to hit edit, and we need to start scrolling down. Oh, adaptive UI. But we do have to tell it what adaptive UI it is and whether we want to use a screen and all sorts of stuff. So let's go over some of the command options. Now you are going to have a lot of leeway here. These might not be in the same order depending on if I reorder them or not, but you have a lot of freedom in how you want Mimir to work. We have been accessing Mimir and looking over here on the side. Whenever we run into a bug, we can try and debug using what's on the side. If you would prefer, you can have Mimir print to a screen. That's usually better, and so you could just set log screen here to true. Now if we were to leave the log screen equals here, the string blank, as a null, Mimir will print to the closest screen we can find. So if I were to hit remember and exit now, one of these screens would have Mimir written all over him. Log to screen is true. How odd, it's not logging to the screen. Well, I'll fix that before I go live with it. It should be logging to a screen for some reason. It probably is. It's probably logging to this screen here. Nope. I'll figure that out and make sure it works before I go live. I must have broken it at some point when I wasn't looking. Oh, embarrassing. But that'll print it to the nearest screen, and you can also name a screen if you'd prefer. So we're going to go ahead and change this back to false because we want all of our screens to not be that. Survival mode. This is important because energy is free in creative mode. So if we have a reactor that has no uranium in it in creative mode, that's still considered to be on. But a reactor that has no uranium in it in survival mode is considered to be off. And so that's obviously a distinction that you are obviously going to want to make. Use named groups. If you are the sort of person who clusters things into named groups, you can turn this on and you can reference the groups by the same names that you would reference for blocks. This does bleed memory a little bit, so only use it if you are that sort of person and don't use it if you're running every tick. Here are the settings for running Mimir a lot, and we're not going to do that. So we can also change the command separator from a semicolon if you prefer, but I would leave it as a semicolon. Now we're into the adaptive UI stuff, which will probably be at the top when you look at it, But here we have the header that we'd like to use, and we also have the screens we'd like to print to. Now here is where we would put our command panel. So, command panel. We have an option for how many options we'd like to print to the screen. Because the because the default button panel has 4 buttons, 4 is the default, but you can change it to whatever you'd like. And then we're out of stuff and we just get into the commentary. So if we hit remember and exit now, everything should work. But we haven't actually built any adaptive UI. So what sort of adaptive UI do we want? How about this? If exists special drill, do something, I don't know. Else mission reconnect driller. Check code, please. So here you can see that our panel is... There we are. Our panel is saying reconnect driller. So it's telling us that that's one of the missions we should do. Alright, neat. Let's go ahead and punch in some more stuff. So if the special drill exists, that means that it is something that we have understanding of. So we can then say if local special drill. In this case, we know the drill is parked. Do we want to give a command if the drill is parked? Maybe not. Let's go ahead and just move on. How about, though, if we had a refinery? Let's go ahead and build ourselves a refinery. Refinery. Let's just plunk it in... here. Yay. Yeah, we'll just have one refinery. On the other side, we'll put our various other things. So that refinery should be named refinery, but let's double check here. Refinery, yeah. So in that case, we're going to go in here and we're going to say in our UI, if our special drill is local, if is low refinery mission go mining. So here's what we've just done. We've said if the special drill exists and it's parked and our refinery isn't refining anything, then go mining, because you obviously are out of ore. So you can now see that it says reconnect driller. We're going to go pop on over to our driller, reconnect it. Go mining. Neat. Well, what else can we do? Let's pop on over to the driller a little bit more here. You know, there's a couple of screens here. The text miner left and text miner right screens. Maybe we should memorize those. You never know when a text screen might come in handy. So, memorize text miner left, memorize text miner right. That's easy enough. What are we going to do with that? Well, if the miner is not local, how about we give ourselves the option of telling the miner to come home? Oh, no quotes. Text miner right dot text come home. So adapt is an adaptable UI entry, and so this is going to add this entry into our interface. Let's just check our code, hit remember and exit. Let's take a look. Go mining. Okay. Whee! We're mining! Yay! We're mining! Wah! Call miner home. The buttons don't do anything. Well, there's a reserved command, so we just go in here to the buttons and we set them up. Now keep in mind that when you're calling our Mimir, you're going to want to use, this is in the comments, you can read it if you'd like. You're going to want to use 0 as your first button, because it's a 0 numbered array. So adaptive UI, 0, 1, 2, and 3. Of course, that's just because of the programming. The 1 is still associated with the 1. So what do you think that did? Shall we go take a look? Oh, those panels definitely say come home. Obviously, it would be best to adjust their size. There, something like that. We could also put a sound block on, maybe memorize a sound block. We could, since we have the drill memorized, we could toggle the drill on and off rapidly and make it do loud things. So here you can see how you can add in adaptive UI elements. Now if you look at the ship I'm providing you, I have a lot of adaptive UI elements on that ship, more than 4. When you have more than 4, it'll clip it to 4. So that's good, right? That way you can have 85 and only the most important 4 will be on the screen. The first 4 that you set up will be on the screen. But this is not where we actually want that to be. We actually want it to be here on Command Panel B or Command Panel A. So let's go back on over, Edit, and we can go and add in Command Panel B or Command Panel A into our list of screens. And you can see that now it is trying to be another command screen. Easy enough. Now if we wanted to get really advanced, what we could do is make it so that that right-hand screen would actually stop updating when you weren't sitting in the seat. But rather than doing that right now, we're just going to go ahead and remove it from the commands that we were creating here. Command Panel B is now a menu, so there's no need for us to override it. We'll only override Panel A. Now, obviously, we can simply do the same thing here. Adaptive UI 0, Adaptive UI 1, Adaptive UI 2, Adaptive UI 3. It works, although obviously it's asking us to do something. It's not a command anymore. It's just a mission. So we can back up. So I think you're starting to see the power that this can bring to the table. Now I've only shown you a brief glance at the sort of things that this makes possible. I will also give you links to 2 ships which use this. One uses an older version and one uses the release version. And I think that you will be pleasantly surprised. But there is one more thing that I haven't talked about yet. So we're going to go ahead and talk about it. That would be the set, unset, and isSet commands. Now this is important because there are times when you're going to want to set a variable even if you don't want to use any C# to do it. So let's take this for an example. Let's go back over to here. And let's change this so that it can actually detect ships and not players. So right now, we change this to an X, but if we drive away, we change it to an arrow. Well, what we should do instead is reserve it, right? If someone parks here, we should reserve it for them. Maybe for a specific length of time or something. But let's go ahead and reserve that if there are people. Okay, that's still too close. I gotta move it far enough away that the see. There we are. So what we're gonna do is over here. I forgot these are still built-in commands. So these sensors aren't using cached commands. They are using manual commands, which means that we're going to have to change them, and that's annoying. So let's go ahead and rip these guys out, and we will replace them with new commands. How about the command parked A and unparked A? So we actually don't have parked A and unparked A in our cached commands, so let's add them. Parked A, comma. So we want to do spotlight A dot on and panel A dot image cross, right? Easy enough. We would also like to do set parked A. Let's name it something else, like reserved A. And then here we can say unparked A. Spotlight A dot on, panel A dot image arrow, and then we're done. So you can see that we're setting reserved A here, but we're not clearing it. Now what does that mean? Well, we have a lot of options as to what we want to do with the rest of these functions. If we would like to, oh sorry, this should be spotlight off. If we would like to, we can check whether or not A is set, reserved A is set, and if it is, we can do something special. So, for example, we can say down here in our custom logic, if is set reserved A, what do we want to do? We want to maybe adjust some text somewhere. How about the command panel A, because we happen to have that available. Now this is just a quick slapdash thing, and it's going to override our last responsive panel. But this way we can see whether or not it works, right? I forgot to check it. Yeah. Always check your code. So welcome, Commander, take a seat. See how it's not overriding? What happens if we go and park this thing? We don't even have to park it, we just have to get it close enough to register. Like that. Drill parking reserved. So how do we deal with that? Well, let's go in and make something where we can have another command. Why not? So we can say, nope, not custom logic, adaptive UI, here we are. So we're in the adaptive UI section, and we will say if is set reserved A. Yeah. Then what are we going to do? Well, let's offer us the option of unreserving it. So apply clear reserved port, comma, unset. It can be either unset or unset, whichever you'd prefer. Reserved A. Like so. And let's delete this one because it is annoying. So here you can see our commands are reconnect driller. Now the reason for that is because our sensor only triggers when we cross the boundary. You have to remember that. Sensors only trigger when you cross their boundary, so we've got to actually unpark and repark in order to make that trigger again. Now you could read the sensor and see whether or not it was saying something, rather than using the sensor's built-in detection. It's up to you. It looks like we have an error somewhere. Oh, no block found to unset. What? Obviously you didn't find a block to unset. It looks like there might be a bug in my code where it doesn't properly detect unset commands. I haven't ever done one in code before, so... But it detected the set just fine, and the set is in the same code block. Let's just triple check here. Unset reserved A. I have a feeling that I know what the bug is, and I think I can fix it. Don't worry, this bug will also be fixed. Wait, we never tried to unset. Why is it trying to Oh. See, this is the problem. My head is rotten. Oh my gosh, I am so sorry, guys. We're not doing this. This is apply. Apply is when you pass an argument in to have it happen, as we've seen before. Apply, battery, discharge, sound block. So we're actually trying to apply clear reserved port, comma, that's nonsense. I'm so sorry, guys. We should have been saying adapt. There. Gosh, I'm dumb some days. You can see that we now have the option to clear the reserved port. Now, I wanted to show you that because it contains variables that you can set and unset and check. And that is really, really nice if you have a large ship and you plan to keep a lot of state. Keep in mind that those variables don't survive loading or recompiling, but for ordinary operations, those can be quite nice. For example, you can use them to keep track of what stage you're in if you have a multi-stage machinery system running. You can allow them to reserve spaces for specific people, maybe. The way this could work is you can actually theoretically get the name of the ship and print it. So you could manually save that name in C# code and then print the name of the ship as it's reserved to one of these command areas, and you'd know exactly which ship had parked in which parking bay. But that's slightly more advanced C#. I'm not going to get into that. I just wanted to show you how to use this script. And I understand it might be a little bit complex, so I'm just going to quickly touch on all the things we covered. You can now use basic sensor calls to trigger much more than one object, as many objects as you want, and you have more options in your objects. For example, you can call it to charge or discharge a battery rather than toggle, and you can call it to set an image or text on a text screen rather than only being able to turn it on or off. So that makes all those trigger now timer blocks obsolete. But since that line often gets very long and you can't access it to debug it, you're also given the option of shortening it to something easy to remember and sticking it inside of Mimir, here in the cached commands area. This way you'll be able to edit those commands without having to try and remember what you typed or try and figure out what letter you screwed up. If you call Mimir on a timer, like this, then every block in your ship becomes a sensor block, which fires whenever you want it to. In this case, we've only made our reactors fire, but we could easily, and this refinery, but we could have easily made it do almost anything. And we can also set it to have different thresholds. So for example, we can say if the batteries are below 10%, recharge them regardless of what's going on with the reactors, or something like that. You use that in this custom logic area. So we used a couple of commands like exists, and we used a couple of commands like check high and check low. Check high and check low are events, and exists is just a standard query. It doesn't fire only when something comes into existence. It fires all the time if it exists. But is high, is high also does that. But check high fires when it changes to high, allowing you to turn things into events. So our reactor gets turned off, this will fire, and we will have this happen. Our reactor turns on, this will fire. On the other hand, these fire all the time, as long as these conditions are true, because these aren't checks. So I've got a mix of real standard C# code and eventing that has been made a little easier. Now, this code should not be a big challenge to you, aside from maybe you want to try and remember what these specific functions are, but this is very, very basic coding, the very most basic of coding. It's exactly the same kind of coding that you've always tried to do with timer blocks, except now you can. You can do it a lot more detailed and a lot more complex. And if you do lose track of what's going on, you can always scroll all the way down here to the part that says Mimir, and then just take a look and read, and it should describe pretty much everything that you'll need to understand. Now this can do a lot more, such as control your turrets. It can't shuttle inventory items around, but it can check and see whether something has inventory, like a cargo bay, and it can do a whole bunch of stuff like that. In addition, you can interact with the player using this adaptive UI, which allows you to set up all sorts of interfaces to give the player more information about what's going on in your ship, and also quickly give him a couple of options as to what he should be doing right now, or what he might want to do right now. And that could be things like remotely changing airlocks around, or turning on and off power-hungry devices, or setting the ship to rotate so that it will automatically find the sun, stuff like that. It's up to you exactly how you want to program it, but that is the joy here. Using very, very basic C# code, you can now control your ship and your players. I understand that there's only so clear this is going to be. I can't really make it super easy to use just because it's never going to be super, super easy to use. But I do encourage you to download it and give it a shot. And I'll try and make a FAQ or a better tutorial as questions come in. If you are a little bit worried about C# and learning how to program, this might be a good way to dip your feet in, because it is very straightforward and you understand what you're trying to do when you first set in the door. You understand, oh, I'm trying to make batteries turn on when the reactor turns off. Just make sure you have enough power to run Mimir when your reactor turns off. Anyway, I'm going to go ahead and post this and link and all that stuff. Have a good one.